Hello, everyone, and welcome to Rational Science, the only site on the internet that does physics. Everybody else does math, descriptions. And what do? Well, we do explanations in physics. Just wondered if I was still online. Had problems lately with communication, transmissions. Anyways, I'm going to divide today the show in three parts. First part, we're going to be doing extinction. Lots of issues raised by people with respect to extinction. I guess people are concerned. Maybe that's one issue. The other one is obviously a lot of people are more into politics than into science. And extinction in a lot of these people's minds has to do with political questions, questions about opinions of how the world should be run and whether the politicians are crooks and that sort of thing. And then second part, I'm going to be doing, going to be covering this physics issue known as the quantum measurement problem. Okay, what problems do we have with measurements? And finally, I'm going to address questions that people asked since last time. Okay, so let's get started on extinction. Person says that I am an animal. He accuses me of being an animal. Yeah, I'm an animal, especially in bed, uh, yeah, I'm an animal and very proud of it. Okay, and you should be too because we are all animals. And the way we do it in science is we have to define what an animal is, and then you either fit the category or you don't. It's just as simple as that. So let's find out what an animal is. Okay, this is the official version. Okay, out there, and it says that we have rocks and minerals. Those are not animals. Those are not living entities. Okay, and then you have viruses, proteins, and other you could say inert matter. They're just molecules. A virus is not a living entity. A lot of people think they are because they say, well, they move around, they get us sick and so on, so it's got to be something that is alive. And that's not true. A virus is just a very complex molecule, just like a protein is a molecule, just like DNA is a molecule. And the virus only works its magic when it gets inside a cell, and that's where it starts, you could say, moving. Okay, what it does is makes copies. It's a molecule that makes copies of itself, essentially. Same with DNA, by the way. Other than that, well, you have what we know as living entities, and you can fit yourself in any of these categories that you wish to to fit in. If you're not an animal, you are insulted by by someone saying that you're an animal. Well, you can be a tree or a flower. Is that what you are? Are you a plant? Are you fungi, algae, bacteria, archaea? I mean, what are you? If you don't fit any of these categories, perhaps, just perhaps, you're a Martian, okay? Uh, you're kind of green, maybe some kind of mixture between something that's alive and not, maybe between plant and animal. So yeah, we have to define what an animal is, and the way we define it is there you see some of the things that an animal does, and that's how typically people define these words. And it says multicellular, eukaryotic organisms that consume organic material, breathe oxygen, are able to move, can reproduce sexually, and grow. Okay, eukaryotes, they're organisms whose cells have nucleus enclosed within a nuclear envelope. And prokaryotes are unicellular organisms that lack a nuclear membrane or enclosed nucleus. Okay? Essentially, what it comes down to is that I hope I'm still on. I get an error from YouTube. So if someone could confirm that I'm still alive here, YouTube again is telling me that I get an error. I don't know where I'm receiving these lately. But if you can hear me fine, we'll continue. Anyways, let me continue anyways. And so let me put this up there. Here it is. And these are the differences between a prokaryote and a eukaryote. And then at the bottom, you see the differences between plant cells and animal cells. Okay, and that's what distinguishes us from plants and other. Okay, thank you. I hope you can hear me fine. I hope you can read all this and listen to me, hear me fine. Okay. Anyways, these are the differences between prokaryotes and eukaryotes, plant cells and animal cells, and you either fit on one side or on the other. And if you don't like these definitions, well, what you can do is define the word scientifically. That way we know what you're talking about when you get, when you get excited when someone tells you that you're an animal. What would you like to be called? A plant? A rock? A mineral? Okay. What should we call you? What category should we put you if not in the animal category? Okay. And again, we're not talking about everyday language. We're not talking about out there, the ordinary speech. We're talking about scientific language. This side deals with science. So we need to define these terms so that we can use them consistently. And there you have, at least we should be able to distinguish between a plant and an animal and, a rock. Okay, we should be able to establish a difference. Okay. Okay, along the same lines, a fellow says, or asks, says, it can be assumed that higher terrestrial life developed. Higher terrestrial life. I don't know how high or how low terrestrial life is. These are opinions. What is high, what is low? Is high an eagle? Is that what's high and low is a fish because he's in the water? I mean, I don't know what high and low mean. Okay, so you got to clarify that. But I'm concerned about another word, and which is the one that concerns biology. And there's not a single biology on Earth that's ever learned to define the word life. And it turns out biology is the study of life, or so they say. Okay, hopefully it's not. Hopefully biology is some kind of explanation and not just a study of. Okay, but here it is. Here's a definition for life, okay, so that we can use it consistently. And we go with the word living or alive. What is a living entity? Okay, and it's a natural object that self-propels against the path of least resistance, primarily against gravity. Okay, so if you can move towards against gravity, okay, then you are a living entity, and if self-propelled, obviously by yourself, okay, of your own volition. And there you see the unit of life. It's the cell. Okay? A couple of examples. One is a single cell. The other one is a cell moving through other cells, I guess. Okay. So this is what life is, and what you got to do is define life, and whether these are higher or lower, that's an opinion. I'm not sure how you can categorize that. We typically look at bacteria and cells, single cells, as something that is so basic. I guess we call them lower forms of life. Okay. But those are, again, more important is to define the word life so that you can use a consistency in the discipline known as biology. Okay, another issue raises, and he says the following. Down syndrome. People have healthy children usually on nutrient-dense diets. This is reversing the degeneration. This individual believes, like many out there, that food somehow changes your genetic degeneration, maybe from one generation to another, and so there are people who believe that by eating, they can reverse things like genetics, your genome or whatever, I don't think so. Okay, your friend could have. He's referring to a friend that I mentioned the other day that has. She was missing one chromosome. Instead of 23, she had 22. Because of that, her muscles deteriorated. And the last time I saw her, which was some years ago, she could barely stand up. She could barely move her arm. She was getting very weak because of her something affecting her muscles. And she inherited that from her father. So this fellow says, your friend could have healthy children if she was careful to consume a nutrient-dense diet with conception. I don't know, maybe, could be, some sick people do have normal children. I know, in fact, of one case specifically, a high school gal. She had all kinds of problems when she was young, in fact, to this day, but she had very healthy children. Maybe what she had was not genetic. Okay? So the issue is genetics here, whether you can reverse some kind of genetic process or some genetic constitution that you have, some serious problem that you might have, if you can reverse that by eating, by just changing your diet. And I'm not so sure that's the case. I'll give you an example. Lions eat meat, cows eat grass, and both of them, because of their different genetics, they produce meat on their bones. You couldn't tell the difference much. I mean, there are obviously differences, but they're both mammals. One is a herbivore, the other one's a carnivore, and yet they eat such widely different foods, and they both put meat on their bones, and they both have bones, by the way. And they're constructed, also with a head, 4 legs, etc. So I'm not sure you can say, well, I'm going to eat asparagus or whatever, and I'm going to have, my kid is, instead of 4 legs, he's going to have 3 legs. I don't think it's going to work. He'll come out with 4 legs, believe me. Okay, another fellow, lots of people ask questions regarding politics, and this fellow came along those lines. He says, war has nothing to do with the economy. When the economy goes south from their manipulation, war is all about politics and corruption in government. People are so much into politics, and they should quit politics. They should get out of politics completely. What can I say? See if I got something here now to show you. But what I'm saying is that you should get away from politics. Politics is, no country in the world is different. They're all the same. They all have a mafia that runs the country. Some call themselves communists, others call themselves capitalists, free markets, mixed economies. They have all these different categories. They're all mafias. They have a mafia on top that rules the country, and they have their influences, and they put those influences in motion. They do something with those influences, those ability to influence the country. And so because they can do that, they manipulate the country any way they want. And it doesn't matter if you say, well, I'm going to vote him out of office next time around. I'll get someone else. And the next guy that you get does the same thing. And over and over and over, since at least since we've invented civilization. So nothing has changed. And no, I say war has to do ultimately with economics. What is economics? Management of resources. There you see, a fellow even said that. That's what economics is. It's management of resources. And when someone stands in the way of your resources, what you do is you fight them. Lion has to fight another lion because he's in the way of his resources. Primary one is food, but he would like to have the harem, okay, the pride, so that the gals can go out there, hunt something, and he gets to eat, and in turn he protects them. I give you a protection. And so the guy standing in the way is the other lion. So they got to resolve the situation, and usually it's not peaceful. Okay, so no, war is about resources, ultimately, not about corruption and all that. All governments are corrupt. There's no difference between them. Okay, so why do you think they would rather use bioweapons rather than nukes? Because this bioweapons can be focused on specific populations and races, killing off the locals and leaving the infrastructure intact. Well, hopefully you're not talking about nukes, because nukes obviously will destroy buildings as well. And you do mention nukes. And do you think if they start throwing the nukes as well as the bioweapons, uh, there's going to be anything left in the cities, especially if they drop them on the cities, will the skyscrapers still be there? You know, I mean, I think it's a done deal that when they throw the nukes, at least, that's it for man. And of course, also if they superimpose upon that bioweapons. Okay, so bioweapons are designed to leave buildings and roads intact. Okay, yeah. The bioweapons are designed to kill people. The nukes are designed to kill people and buildings. Essentially, that's what he's saying. Okay, but I like his next statement. He says, "So yes, even more people will die this time around," meaning the Third World War. Okay, in the billions, yes, but not everyone. Well, someone always survives a war, right? And this time we're going to fewer will survive, I guess. If there is a nuke and bio war, a few will survive that. But let's say 10,000 people. Let's say 10,000 people survive on Earth, okay? And you know they're not going to survive the 10,000 in the same place. They're going to be scattered around. And one of the things that's going to be lacking is food because you've destroyed everything. Okay, and so these people will be there in their own little pockets. They won't know that there's someone else on the other side because there won't be any way to reach these other people. Okay, and if you do, you're in trouble because you don't know if they're going to receive you or kill you. You know, there's going to be this trust but verify issue, right? And so here you are in your little pocket. What do you think is going to happen? You think do you think you're gonna reproduce and have children, start the Adam and Eve things all over again? No. First of all, our genetic diversity is gone. We have very little genetic diversity, meaning that even if you reproduce a couple generations later, that's it. More than likely, you're going to be worried about subsistence farming. You're going to be producing food for yourself. And it's not going to give you much time to reproduce, or would you want to produce another individual that is not going to do anything for you except be, you know, just someone else that you got to maintain, okay, a dependent. And then you have the issue of what for? Why would you produce another child? Do you think you would have the psychological fortitude after a world war where everyone's gone around you? Do you think you would have the fortitude to go in there and say, okay, it's business as usual, I'm just going to have a kid? No, those people who survive will just live out their lives. There won't be any reproduction. And so even if a few survive, it's going to be the end of man one way or the other. It's just going to be staggered. It's not going to be all dying at the same time because of nuclear war. There's going to be some differences between the war, when they stop throwing the nuclear weapons and biological weapons, and whoever survives, well, he survives until he dies, and that's it. That's going to be the end of man. So we're talking about the extinction of man one way or the other. So yeah, everyone will die sooner, a little later, but not sooner, but a little later. Okay, but they will all die. And so he says, if economic is management of resources, where do you get war out of that? Again, war has to do with managing resources, and you would always like to manage the resources of the guy that's on the other side, who's standing in your way. You know, a lion has to fight another lion because this guy, the head of the pride, he's standing in the way of his progress, of his resources. So yeah, war is about resources, ultimately. And you are describing the collapse and extinction of our current form of government, not humanity. No, government, the day government collapses, that's the end of humanity, okay? There is no way to live without government, okay? And even if we live without government, the first thing we do is create a government. We create the rules, the laws. It's part of our social culture. That's what we are. We are essentially we are social animals. I'm sorry, I said animals. Oh, we are social animals, and social animals need a government. Okay, not that we want to have it, but it's like a government always uh, pops up. It comes out of nowhere. There is no such thing as a few humans without a government. Someone always rules or has most of the influence. Okay, here's another issue along the same line: war. People are concerned with war, and I think we should be concerned with war because I think we're headed that way. Probably, very likely that if there is a clash, somewhere it could escalate. Okay? It says, "Is a world where people only have one kid, do you think they will be as eager to send them into war?" Well, the next war will not be with people. Okay? It'll be pressing buttons. Again, we're talking about nuclear and bioweapons. It's going to be a button war. You don't need people for that. You just need 5 fingers in each hand and be able, especially the index finger, just press buttons. Okay? So a lot of the war, even conventional war today, is done like that. They send those missiles from the ships all the way to where they want them. So a lot of that is already being done in one way or another. Okay, another comment, issue, question someone raised says markets have already been disrupted. The crisis is not in the market; it is in the government. People are so concerned with politics. Try to maintain your mind on uh, science. Causes. Causes primarily, not opinions, not recommendations, but causes. Okay, physical causes, especially. In this case, we're not talking really about. We could talk about causes when we talk about war, for example, or markets collapsing. But the issue is also a philosophical issue. We want to know the reasons and the purposes people had for investing, for that sort of thing. You have to have an explanation. Then you're doing science. Otherwise, you're doing just philosophy, religion, which is opinion, which is recommendation, which is how government should be run, and you don't like that other government, and so on. That's all opinion. That's religion. And then he says there is a cycle to food. I have no idea what that means. You would need to clarify that in quite a bit of detail for me to even address it. Okay. Next issue, fellow says money is the most saleable good, usually gold. So it's not a concept. The word money is a concept. Okay, money is a concept. Now there are different diverse forms of money. You have gold, which is tangible, meaning the rock, the coin, whatever you have in your hand. That's tangible, and that's an object. But money, the word money, is a concept. And essentially it means trade. You're exchanging goods or services or whatever. You're exchanging. Money means exchange, essentially. Okay, that's what the word money represents. It's the medium of exchange or the currency we use to do exchange. But it's also could be a solid product. And one of the products is food. Money, food can be money. Okay. The problem is we're not used to real money like gold, and instead we're mostly using counterfeit money. Again, opinion. Counterfeit means the guy has a political opinion. A recommendation, maybe. Don't get that money because it's counterfeit. Okay. Here's another question along the same line. Paul says, let me get this here right. Money, the good and highest demand in a given economy. Good luck ever having an economy without a good in highest demand. Well, the day that the global economy collapses, okay, then food will be the only good in the highest demand, the only demand. And that'll be the only resource you will manage, meaning you will have an economy or management of resource, You'll be managing food and you will not have money because money will be no more. You will no longer trade. Okay, you will no longer trade like we never trade in, I don't know, in the Paleolithic. There was no trade. Okay, we invented trade when we invented, after the Neolithic, when we invented commercial farming. We went from subsistence farming where you produce for yourself, your family, your clan, whatever. And at some point, people started exchanging things because they were able to primarily have trust. Without trust, there could never have been um, exchange, money, trade. You have to have confidence. You have to have faith, and that did not exist in the Paleolithic, even among humans. The Cro-Magnons, the Cro-Magnon, there was no trade between them. It was like the lions. A guy who was from a different clan, he was your enemy. He was a different country, let alone if he's a different species like Neanderthals. You have people out there, paleontologists, who say that the Neanderthals and the Cro-Magnons traded seashells, I guess for prostitution. I don't know. Maybe to sleep with a beautiful Neanderthal gal, hairy. Well, you got to take your clothes off. She doesn't. Okay. Another issue. Fellas, can you elaborate on why you consider service jobs to be the same as being unemployed? Okay, so let me address that issue. I've addressed it more or less in the past. I'm going to give you a little clue there of why I consider this. It's not part of our. What was I going to say? It's not part of our material world. Okay, it's part of a world in which we have all these services, these abstractions, and so I distinguish abstractions from solid things, from objects. Okay, so that's the first difference we have there. But here, let me give you the analogy. Okay, or a little story. Okay, here it goes. And the way it works is this is God, and He's looking down on the world. Okay, and He's what does He see? What is it that He sees? Well, He sees the things that we constructed. He sees the buildings. He sees the land for sure. He sees the crops that we planted or are about to be harvested. He sees cars. He sees ships. He sees I don't know, everything we built, bridges, roads. That He sees. He doesn't see insurance. What is insurance? Insurance is a promise. So those people who work in insurance, they say, well, I got a job. I'm working in insurance. Well, yeah, according to our organization, we call it a job. But the guy's not producing anything, any more than the guy who sings. What is he producing? Well, you can go over all these issues like saying, well, he produces value and he produces something that someone wants to hear and is willing to pay for and all that stuff. He's producing nothing. When you produce an intangible, you're producing absolutely nothing. Okay? God only sees, good old God, He made the universe, right? So He should know. He sees only what's constructed, what's there. And so that's the difference between, like I said the other day, and I'm going to get to that in a second, wealthy and rich, okay, more or less. Well, he's a guy who has something, has tangible things. And so how wealthy is the earth? Well, just look at what you have, what's out there. You know, the countries are always judged, whether they're advanced nations or backward nations. How do they judge that? How do they come up with all these notions? Well, they look at how developed the country is. I mean, how many roads does it have? What does it have? You're looking down through the satellite or through God's eyes, and what do you see down there? Well, if you don't see much construction, you see just farmland and, services, okay? There's nothing there. What you're going to look at is what's constructed, what is tangible. That's what really has value. The promise for example, insurance, that's nothing. And you say, well, yeah, I'm going to collect when I get sick. Someone pays for my doctor and they give me services. They cure me. They operate on me. You know, the day the global economy collapses, let's just assume that, the only thing of value will be what God can see. All those promises like insurance, they're not there anymore. They vanished into thin air. The singing, that went away. All these things that people did, all the verbs, they disappear. The only thing that remains are the nouns. And that's how you can tell the difference between, what is and what ain't. What is are the things, what we constructed, what's already constructed, what we built, and the food. Obviously, these are the tangibles. The intangibles, I don't know. Gone with the wind. Okay, one fellow says, maybe a debt jubilee will be the last-ditch attempt. Yeah, I think this might actually happen, that maybe the last straw will be that governments will somehow deal with the debt in such a way that it will be part of the global collapse, of the global economic collapse. So I think one of the processes that will eventually happen will be that there will be a jubilee for debt, and that might be one of the last steps that governments take, because after that, I'm not sure what tools, both monetary or fiscal, they can apply to restart the global economy. What are they going to do? Print more money? Devalue what's already been devalued to close to zero, to having no value because nobody wants the money. Why? Because they can't reach the end of the month with what little money they're given and so on. So yeah, I think the debt jubilee is part of that process. Okay, here's the rich issue, rich versus wealthy. Okay, and Phil says a rich guy has purchasing power. A wealthy person also has purchasing power. Right, so there's no difference, right? A poor person has less purchasing power. Yeah, okay, we understand now. Finally, we understand. The rich and the wealthy have nothing to do with your extinction event. Never said they did. In fact, let me put the answers here to them so that you can see them side by side. Okay, here it is. What this fellow is saying, he's saying that the rich versus the wealthy. All I'm saying is that rich, I'm redefining what rich is and what wealthy is. Rich is a person who has liquidity, has money, but does not have things. And wealthy is a guy who has things, but does not have money, does not have liquidity, anything to trade of that is liquid. Now, like I said, a rich person can become wealthy by buying things, and wealthy can become rich by selling things. No problem at all. But I want to keep those two terms separate, rich from wealthy, so that we can use them consistently in a dissertation. Okay, that's the point. So we're not using the terms of ordinary speech. We want to give them some scientific meaning so that we distinguish rich from wealthy. And, I was going to say here that, let me put this aside for a second. I put there blue bloods versus dilapidated castles, or having dilapidated castles. Here in Germany, you have people who are blue bloods, and by that I mean, they descend from big names of the past, and so they inherited these names, and they inherited maybe a castle. So the guy, you'd say, oh man, he's rich. Turns out he's not rich. In fact, he's more or less on Social Security. He depends on the government to help him out with handouts, either through welfare or some form of help, coming out of taxes, by the way. And you say, how can that be possible? The guy's a blue blood. He's got a castle. Yeah, the castle, he might have a dilapidated castle, or a rundown castle. And it turns out that he's got no money. After centuries, maybe his father, maybe he himself, they liquidated all their money, played it at the casino or whatever, and lost all his money, or maybe investing. And the guy has no money. He's a blue blood without money. He's wealthy, but he's not rich. Okay. Now he's got this castle, but nobody wants it. And it's got a little bit of history, and the guy carries the name. Maybe he's a Habsburg, and he's got the castle. And now what does he do? Nobody wants his castle. He doesn't want to really sell it because he's tied to it culturally. His family owned it for centuries. What does a guy like that do that doesn't have any money to do anything with that castle, to even, prop it up? And so what the government does, they give him money. They say, look, we'll give you money, and it's going to be good for Germany because we want you to fix this place up. You stay in there. You're going to be the tour guide, the Habsburg tour guide by Habsburg himself, and you can tell them about your family's history, and we'll give you money. We'll give you a salary, and all we want you to do is fix up the castle so that it's good for tourism. So the guy is really wealthy but not rich, and he can't sell that castle, partly because maybe nobody wants it or few people, there's not much of a market for it. Another is that maybe the government doesn't want anyone to buy that because it's one of those things that the government tries to keep forever, historical landmarks, etc. And so that's the arrangement they have. They give this guy welfare money in order to keep the castle running. So yeah, it's not the same thing to talk about wealthy and rich. Okay, that's the point I wanted to make there. Then the next the next issue is the rich and the wealthy have nothing to do with your extinction event. Well, I never said that they did. Okay, so I don't know where he got that. I never said that the rich and the rich and wealthy have anything to do with extinction. I'm saying something else. I'm saying that I'm just distinguishing between rich and wealthy so that we can use these words consistently in a dissertation. And then we have this issue that he raises. He says the haves and the have-nots. I brought that issue the other day, saying that in the future, when the world economy collapses, there will be only two kinds of people. And some will be the haves, the other ones the have-nots. And the haves will be those who have food, and the have-nots will be either those who don't have food for a short while, and then they'll be the dead. Okay, so that's the way you got to look at that. And so I don't do politics anymore. To talk about Marxism is, for me, politics, and it's just opinion. Okay, Marxism is no different than capitalism because all countries that claim to be capitalist, all countries that claim to be Marxist, what they do is plain old half and half. They do what is called a mixed system. Okay, some things are capitalist and some things are communist, and you'll see that in every single country of the world. There is no country that is purely capitalist or purely Marxist. Schooling is typically Marxist. Health in many countries is Marxist. What other things? Anything that is social welfare, unemployment, Social Security, all that stuff is communism, Marxism. You could say it. I mean, that's where it would fit. And then you go to China. Is it a communist country? No, it's a capitalist country. Totally capitalist. It's got a dictatorship, yes, but underneath, it's all capitalism. Everybody can buy and sell and own land and all that kind of stuff, And so it's capitalism. There is no such thing as pure capitalism, pure communism. Every country in the world is a mixed system. Is that the best way to govern? Well, I don't know. That's an opinion, not part of science. Okay, continuing here, getting more into the subject matter of extinction. Person says the dinosaurs lived for millions of years before the sun killed them off. The sun killed them off. Well, how did the sun do that? I hope he's talking about the sun and not a son like my son, not like that, okay? He's talking about the sun. So what is the mechanism? How did it do it? You got to tell me how the sun managed to kill us off, kill the dinosaurs off. What is the mechanism? So, yeah, I mean, people just say these things, but they don't have a mechanism. They just, the sun killed them. Did they fry him? Did the sun fry him to death? Is that how these animals died? My God. Okay, and so here another person says mainstream scientists blame climate change for dino extinction. Not really. Okay, I'll get to that in a second. Some vary on what caused this climate change, asteroids, volcanoes, CO2, but I'm sure they agree that it was the effect of climate change on food that killed off the dinos. I don't know. Here's the outline. Let me give you an outline of what mainstream believes for the dinos. Okay, here it is. Okay, these are the steps. First, an asteroid hits the Earth. There is a climate change, but you got to put it in the right context, okay? Because there's several aspects to that. One is the impact winter, okay, which is the cloud covering the Earth, and so now you don't have any photosynthesis going on, so the plants die, okay? When the plants die, well, guess what? Who follows next? The herbivores, right? And once they are no longer around, guess what? The carnivores are out. Okay, so this is more or less the sequence of events. The problem here is that impact winter, cloud covering the Earth, dust, cloud, etc. Question is, how does that produce selectivity? How come some animals die and others continue if photosynthesis is the same for the cactus as it is for the cycad? Cycad being the ancient plant, okay? Primarily, you have these cycads, Williamsonias, cycad-likes as they were called, some of them. These plants disappeared, and magnolias, those continued. How does a dust cloud that affects the entire planet, distinguish between one and the other? And so unless you can answer that selectivity, that's what it's called, you have no theory. And that theory of the dust cloud doesn't explain anything. Doesn't explain what a mass extinction theory should explain, which is selectivity. So I don't know how to get that notion across to people. People say, well, it was this, or it was that. Yeah, but you got to explain the selectivity issue. If you can't explain it, well, what's the point of just stating stuff? Egg predation I mentioned the other day, or someone mentioned gravity. Okay, fine. So you say egg predation. How did that work? Well, they say they have all these little mammals in the case of dinosaurs, right? They came around, they started eating the eggs of the dinosaurs, and so the new generation of dinosaurs did not appear. Well, the first problem is, these little mammals, they were around for millions of years. Why didn't it happen before? It's like saying that the cockroaches are going to drive us to extinction because they're going to eat all our food in our fridge, or kill our babies or something. Yeah, please explain it. How that's going to work out. You got to explain how these little animals didn't do it before, and then you got to explain. Okay, so that happened on land. What happened in the seas? How did the reptiles disappear? Did tiny animals eat their eggs in the seas? And if so, why didn't it happen before? Why did it happen 65 million years ago, more or less? That's what you got to answer. Okay, so. What can we say? These theories don't work out very well until you can justify them. Okay, person asks, are there signs of reduced size in fossils, in the fossil record in a few final generations of that conduced to mass extinctions, right? Human beings are the fattest we've ever been, so I expect our great starvation will start at least 50 years from now. Okay, let's address the first question. It says, is there any evidence, for example, in the case of the dinosaurs, for the fossil record where the final generations reduced in size? Okay, there is one process known as this island constriction, where Some animals, like elephants, that got stuck on an island, or also the mammoths that got stuck on an island, and they start shrinking. Okay, so there is a process like that, a million year process, thousands, hundreds of thousands of years, where these animals actually shrink. Okay, so there is a process like that. But in general, what we see in mass extinctions is the following. Here's an example, and it's from the Cretaceous, and here it is. This is an ammonite, okay, that was found in Germany, and it dates to the end of the Cretaceous. And you can see that they're big. It's 6 feet tall, 6 feet in diameter. And so animals did grow big in those days, towards the end of the extinctions. And I'm not only talking about the Cretaceous, I'm talking as well about, for example, the end of Permian, they were big animals. End of Triassic, big animal. End of the Jurassic, we had the biggest animals on Earth before the whales came around. So, always towards the end of a mass extinction, the animals are big. That's the first clue. The second clue is they are old. They've been around for a while. The animals that die in a mass extinction are always, always, always old. Okay, so keep that in mind. It's the old generation that passes the baton to the new generation. That's what happens in a mass extinction. So those are the things that you got to look at. And if you don't believe me, well, you go out there and do your research and reach your own conclusion. Those are the assumptions under which I work. And you say, well, okay, the Ammonites were big. Well, yeah, it turns out that the mosasaurs, which were monsters, sea reptiles, they fed on Ammonites. That was apparently their biggest lunch or dinner, the element, the food. That's what they wanted to eat. That's what they ate. So what did these guys eat? Well, they were filter feeders, and so these folks ate this. They ate forams, and here you see the difference between the forams and the ones that came after. You can see the sizes, the differences in sizes. The ones on the left, which are the end of the Cretaceous and that disappeared, they were monsters. For being plankton, they were huge. They were the dinosaurs of the seas, of the world of foraminiferous. Okay, and what do you see on the right? Well, those were the new ones, and they started all over again. These are the ones that were going to radiate during the Tertiary, which is essentially, our world today. So these expanded, and they disappeared as well, many of them. Okay, but yeah, towards the end of a mass extinction, the animals grow big. We are an example. We were smaller in the past, way in the past. If we take it to Homo habilis or even Homo erectus, we were bigger in general. Okay, so keep that in mind. Towards the end of a mass extinction, animals grow big. In fact, today, among modern humans, which you can maybe date to 200,000 years ago, you're right, 200 or 300,000 years ago, we are the largest that humans have ever been. So we are the T-Rexes, if we're going to use that as a size comparison. We are the T-Rexes of our lineage. We're the last of our kind, the last of the hominids, and of course we are big. It doesn't get any bigger than us. We're not going to grow much, much bigger. But today we see, people in Holland are I think the biggest people, the tallest people on Earth as an average. And man, they are huge. They are the T-Rexes of humans, of man. Okay, a couple more issues here, I think. Here it is. I just want to say that we do want to do Extinction 101 before we do 102, and some people try to meet that standard. Okay, we want to make sure we understand a mass extinction before we extrapolate that to a human extinction, which is Extinction 102. And I always leave you, or I try to leave you from now on, with this question, which gives you a clue to why mass extinctions happened. That's what I'm going to argue, okay? And that is, the homework is, why did the fauna in the seas disappear at the same time as the animals on land? If you can figure that out, if you can figure why that happened more or less simultaneously, well, I think you've figured out a very important clue of how Mother Nature does her mass extinctions. Okay, so let's move on to the lecture today, which is about quantum measurement. Here it is. What is this quantum measurement problem? Do we have a problem in measuring? I mean, what do? You take the measuring tape, you stretch it across the table. Why would that be a problem? Okay, see, it sounds like a straightforward thingy, right? Okay, and here it is. Okay, it's the quantum measurement problem. These are essentially the main points. How or whether wave function collapse occurs. Okay, I like the fact that they say whether, not just how, because if you say whether, you mean maybe it doesn't occur, or what are we trying to answer here? Okay, if it doesn't occur, then there's nothing to answer. Only if you have that how, then yes, you would try to answer how it happens. You know, what caused it to happen. But if they say whether, are they saying that sometimes it doesn't happen? And we're going to get into what a wave function collapse means, okay? But keep that in mind, okay? And it says the inability to observe such a collapse directly, okay, has given rise to different interpretations of quantum mechanics. What are we saying here? Okay, something very important. They're saying inability to observe. Okay, I thought mathematical physics harped upon observation. They say you must observe. And here these people are saying that we have no ability to observe, okay, the wave function collapse. So is this outside the bounds of science? Is that what they're saying? Because we have no way of testing the hypothesis, as they say? Okay, so keep that in mind as well. And then the other one, the different versions of, you know, these interpretations, right? Pose key sets of questions that each physical interpretation must answer. And that's what it comes down to. What these people have done is they've come up with all sorts of physical interpretations for this unobservable, this by its very nature, this unobservable phenomena, which they call the measurement problem, which means the wave function collapse. So they have no way of seeing it. They have no way of testing it. All they can do is describe. What do they describe? They describe what they can see, what they can take pictures of, maybe what they can simulate with their computers, but they can't see the mediators themselves. And so they're guessing. And no problem there. They can hypothesize, as it's called. They can theorize. They can say, look, I've got an idea how that could happen. That's no problem. The problem here is the irrational explanations you're going to hear next of how these people have answered this so-called wave function collapse. Okay, so here it goes. Here's well, first let's get to the measurement. What is a measurement? I mean, what are they talking about when they say we have a measurement problem? Okay, so what is a measurement? Well, here it is, okay? And it sounds pretty much like the story of the Emperor's Clothes. I think they're trying to sell you a Whopper, okay, with all this wave function collapse. It says the testing or manipulation of a physical system in order to yield a numerical result. So they're going to manipulate a system of some kind, okay, physical system, could be a table, a chair, right, in order to yield a numerical result. They say this table measures 1 meter, okay? But how do you measure something you can't see or touch? Does it make sense to go to the lab and measure that which you can't see or touch? What are you measuring? Are you just, you know, stretching your measuring tape across space? Nothing? Is that what you're doing? You know, what are you measuring? The length of nothing? This is the issue. And so the predictions that quantum physics makes are in general probabilistic. Yeah, they're probabilistic because they're going to be doing math. they're not going to be doing science. They're not going to be doing physics. Okay, they're not going to have an explanation for you. What they're going to be doing is measuring speed, energy, mass, charge. They're going to measure parameters. Okay, and that's what they're going to call science. When it's what is it really? It's mathematical physics, meaning mathematics has nothing to do with physics at all. Physics is explanation, math is description. What these people are going to do is give you a description, and the explanation that they're going to give you is just going to blow your mind. And here's the first one. Okay, what's the first explanation they give for the wave function collapse? Well, here you see it. Came from these two fellows, primarily from Heisenberg, the guy on the right, lower right. It's the Copenhagen interpretation, and that's the most popular still today after almost 100 years of quantum mechanics. An irreversible process causes the decay of quantum coherence, okay, which imparts the classical behavior of what? Observation or measurement. They call those are classical behaviors. If you can measure something, you're doing something classically, okay? That's called a measurement. But if you're doing something in this world that you can't see, prove, or measure, or whatever, well, then they're going to call it a quantum process. So we have the difference between, on the one hand, a classical process which you can measure, and these that you cannot measure. And that means get a numerical value that you can rely upon. Why? Because we're going to see that it's kind of fuzzy. It's a fuzzy because you're measuring according to them, right? Measuring a wave, okay? And a wave is kind of stretched out. It occupies lots of space. In fact, all the way to the edge of space-time, and it occupies the whole universe. They call it a field. They have all these words for it. But as soon as you take the measurement, that's the one you're going to put down, well, it collapses the wave function and it turns into a ball, okay? And here, let me show you a little pretty picture of that, okay? Here's what they're talking about, okay? Here you have a wave, and it suddenly turns into what? A ball. That's what they're saying. That's what they say when they say it's a wave function collapse, okay? So what they're saying is something converts into something else. In this case, they have this elongated thing, and as soon as you take the measurement, what happens? Well, it collapses to a ball. And that's just an example, okay? So the question is, what is the process? It turns out that they don't explain the process for a specific reason, and the reason is that, you know, they cannot explain it. They cannot explain how that happens. And the other reason is that they're talking about math. They're talking about what you measure, and they're talking about equations. When they talking about when they talk about a wave function, they're talking about math. So they're saying the function collapses. Forget about the adjectives in front of it, wave, quantum wave. Forget about this adjective. It's a function. What do you mean the function collapses? Well, again, it's a probabilistic theory, so it deals with probabilities. And so they're doing math, and they use these terms which are of physics. When you talk about something collapsing, you're talking about something physical. You know, what collapses? Well, you can say the government collapses. Well, yeah, that's a concept, and that's using the word collapse with a concept, with an abstraction. You say the government collapsed, okay, or money collapsed. But when you use it with physical objects, then it's very clear. You say, well, you know, what collapsed was the building. That's a little different. Now you're talking about things. That has to do with physics. The other stuff, you know, has to do with either philosophy, if you're going to talk about reason, purpose, or it's talk about belief, opinion, you know, why you think the thing collapsed. That's religion. But we're going to do physics. We can't use the word collapse and apply it to a concept, an abstraction such as an equation, a function. What the hell does that mean? But see, they give you the notion that the reason they can't measure accurately the location of the particle is because the wave function collapsed. They're suggesting that or more than that, they're actually telling you in your face, they're talking about something physical. They're saying there's this thing called a wave that's waving out there, and then suddenly it collapses to a ball. That's the notion they want to give you. But, when you put them against the wall, they say, well, it was the wave function. And what we mean by that is the function collapsed to a reading, to a value. So they're talking about abstractions, but they're using these physical terms. They give you the impression that they're talking about physics when they're not. They're talking about math. Okay, so that's extremely important to understand in this situation. Okay, and fortunately we have someone on the internet, and his name is Nick Lucid, and he runs a site known as the Crazy Asylum, the Crazies, what is it, the Physics Asylum, the Quantum Asylum, whatever he's called today. And that's Nick Lucid. He looks more or less like Curly of Three Stooges, so I like to call him Curly. And he says, what is actually waving? He's talking about, again, this wave function collapse. He says, what is this wave that's waving? And he says, probability. He answers that question. What is waving is probability. What is waving is a function. Are we talking about physics? Or are we talking about math? How can you say that a function waves? I mean, you see the problem. We're talking about abstractions that are moving, and that is very scary. Okay. Anyways, he continues, says, remember, we're taking a trip down the quantum brick road. Yeah, we're headed to Oz. Okay, here. A wave is anything that has a back and forth shape. Now, what kind of shape is a back and forth? Form, shape, whatever. What is the outline of a back and forth? You see how they use these words? They want to apply a word of physics such as shape, and they want to apply it to what? To back and forth, which is a verb. You can't have the shape of running. What is the shape of flying? What is the shape of swimming? That's what this guy is saying. And they use these words, and it only confuses the dissertation because you don't know what they're talking about. Are they talking about physics? Or are they talking about math and abstraction? What are they talking about? What is a wave function collapse? Okay. So yes, while wave is a verb, he says it, okay, it is also a noun. Waves are things. How are waves things? The flag is a thing. What it does is wave. You can't say that a wave is a thing. But this is how these people talk. And it's, pervaded the language completely. So this is how these people talk. And it is very confusing, especially to the layman out there who's not careful or tuned into really what these people are into or what they're saying. Okay, they say, oh, that's over my head. That's nice to know. Science is so great. And they walk away and they never learned anything because these people talk this way. He continues, says, a mathematical function, he defines it as what? A relation between sets of numbers. Okay, so it's a relation. What is a relation? A concept. That's what a function is. A wave function is a function that looks wavy. Great. Wave function is wavy function. Great. Good definition. Again, these people never learned to define words. That's the problem. Quantum wave functions are a bit more abstract than that. More abstract than that, okay? I don't know. I don't know how much more abstract you can get than that. They're unobservable by definition. Okay, so here we have a wave function. They say there is something there. It's called the wave function. They're talking about a function, which he says is a verb, right? Or a wave that is a verb as well, right? And they're waving it, okay? But he says because, I guess, they're concepts, they're unobservable. Yeah, no kidding. All concepts are unobservable. So should we remove that from science because they claim that science is what you can observe, measure, test in the lab, and here they can't even touch it or observe it, see it? Is this outside the bounds of science? According to their own definitions, by the way. I'm not introducing my definition at this point. I'm using their own definition. They're not being consistent with their definitions. Okay? So the point is the quantum wave function isn't even completely real. He says that, not me, okay? It's not real. I thought physics dealt with what's real, what exists. Isn't that what physics is about? What exists? Isn't that what we're interested in understanding? What exists out there? What causes gravity? What causes electricity or magnetism? What exists out there that we can't see or touch or prove through observation or go to the lab so that we can see or touch it? This is not an issue where you go to the lab and run an experiment. You're not going to figure this out through an experiment. You got to sit back and visualize. You can say, what could Mother Nature be using here to produce all these effects that we can't see or touch? We can't see or touch the mediators of these effects. That's what science is. That's explaining, giving me an explanation how the universe works. But to say that you're going to wave the wave function and that a wave function cannot be observed, yeah, no kidding. I have trouble always observing verbs. Usually I observe nouns. Okay, so he ends up his little dissertation saying the following. Instead of looking at the quantum wave function itself, we look at its probability density. My God, probability. That's what they look at. I hope you can see the probability density. In other words, these people are going to be doing math. So he says, so what's a quantum wave function? Okay, what is it? It's a mathematical entity, calls it an entity, that has no physical meaning. Those are his ending words. So what did we learn? Well, we learned that there's no such thing as a wave function. It doesn't exist. It's not an object. It's not a thing. But he calls it a thing. He calls it an entity. Okay? And what's more, he's going to wave it. And he says, well, because it's not just a wave. A wave is not just an object. A wave is also a noun, a thing, an object. So they're treating it. That's why they use the term mathematical physics, because the physics part is the object that they're going to use, and you're not supposed to take it literally. And then the math part is the description of the equation that describes its motion, and that's the part they're interested in. They say, well, we're interested in this in math. We want to do equations so that we know how it moves. And some of that might have to do with technology. None of any of that has anything to do with physics. Physics is understanding how Mother Nature runs her shop and what mediator she uses to do that. You got to visualize the mechanism. For that, you got to introduce objects that you can't see or touch, because you're going to use them to explain a mechanism to someone else. What the theories, what you have going through your mind, what you're visualizing. Okay. And yeah, you can put ghosts in there, and okay, that's your explanation, fine. Someone might believe it, other people might not. Okay, and again, whether they believe or not, outside the bounds of science. But yeah. Anyways, here we have the second version of this wave function collapse. It's known as the many worlds interpretation. My God, if you thought the other one was crazy, this one beats it by a mile. It says there is only one wave function. Okay, the superposition of the entire universe. So they're saying there's only a single wave function. They're visualizing this as a field, I guess, that extends throughout space and time, space-time. Okay, so what is this field? Well, everywhere it's got all these vibrations. What are those vibrations? They're the waves. It's a single wave, but it's everywhere. Okay, and whenever you pinpoint one, you're going to measure, you're measuring only a piece of this monster, this web that extends throughout the universe. That's the notion they want to give you. The wave function never collapses, according to these people. They say it's constantly there. It doesn't collapse. So there is no measurement problem. So these guys are people who believe in the many worlds. They do not subscribe to the traditional Copenhagen interpretation, which is, the wave function collapses. These guys say, no, there is no wave function collapse or measurement problem. What happens is you have this monster, which is a bunch of waves that form the field, and whenever you measure, you're just measuring it locally. Okay? But what happens? It gets even worse, because it says all possible outcomes of quantum measurements are physically realized in some world or universe. I talked about Schrodinger's cat. Just briefly, let me illustrate it here. Here it is. Okay, I presented this the other day, a couple of times already. That's Schrodinger's cat there. And, for those of you who don't know the story, you put the cat in a box and you have this, uh, what is this poison you can say? It's some radioactive poison that's in a glass jar. And what happens, you break the glass with a hammer that's timed, and at some point, the glass breaks and the radiation comes out. And supposedly it kills the cat. Now, you don't know if the cat is already dead in there, if that's already taken place or not. All you know is that the cat is either alive or dead because you haven't opened the box. Now you open the box, and they say, the quantum mathematicians say, the cat collapses to one of two states. Either he's dead or he's alive. That's essentially what they're doing with particles. Okay, so this is an analogy for the particle universe of quantum mechanics. Okay, what is the issue? Well, the issue with the multiverse theory, in other words, this many worlds, it's trying to incorporate general relativity, the notion that there are many worlds out there, many universes, and what happens is the cat actually lives in all these universes. He branches out in all of them, and in one universe, he's dead, in another one he's alive, in another one he's standing up, in another one he's maybe half dead, half alive because he's maybe sleeping, waking up. So the cat, for every step he takes in his life, he branches off into these many universes, many worlds. Now, what sense can any of that make? Is this a rational explanation? These people study 10 years at the university, and this is what they come up with. They come up with the wave function collapse, the wave collapsing to a ball. We don't know what the process is, but it does so. And the other guys say, no, it doesn't really collapse. The wave or the particle or whatever that branches off into all these universes. And here it collapsed, and here it didn't collapse. Who knows what happened? But they say the wave function doesn't collapse because it covers the entire universe. You figure it out, what they're talking about. In fact, I wonder if they know what they're talking about. Okay, there's a couple more, and I'll go quickly through these. They're not so popular. And this one comes from the Broglie and Bohm theory. These two guys essentially, and lots like them, Einstein among them, they were all wave theorists. And they're a little different than people like Bohr, and Heisenberg, who were more particle theorists. They believed more in the particle. And so it was really a fight between the particle theorists and the wave theorists, and the particle theorists won the day. And eventually they kind of merged it into this notion of field. They came up with a field theory of quantum mechanics. And they like that because it kind of unites general relativity, which is a field theory, together with quantum. And that's what they're trying to do today, somehow figure out how the equations from one discipline, general relativity, can match the ones from quantum mechanics. They're trying to get an equation that explains both sides. Okay, that's essentially what string theory is trying to do. But it says there is no actual collapse. These people don't believe in the collapse either. Okay. System description contains the wave function and also the position of the particle. This is kind of strange because, wave is motion, position is something static. And they say, who was it? Mr. Heisenberg said you cannot have both motion and position, the amount of motion, or you can't zero in how much motion there is if you know the position, and vice versa. If you know the motion, you do not know the position of the particle. And I always like to synthesize it by saying, when the ball moves, it doesn't stand still, and when it stands still, it doesn't move. That's what the uncertainty principle essentially says. And so here we seem to have a contradiction, because this guy is talking about, as far as anyone who's a wave theorist in general within quantum, okay, they try to fix this problem saying, look, there's a difference between the wave and the position, and these people are saying we can have both. We can have our cake and eat it too. Okay, that's essentially what these people are saying, because they're saying there is no collapse. Okay, and therefore there is no measurement problem. Also, like all the guys said, role of the wave function is to generate the velocity field for the particle. Okay, And velocities are such that the probability distribution for the particle remains consistent with the predictions of orthodox quantum mechanics. These people are talking about probabilities, they're talking about predictions, they're talking about descriptions. They're not going to explain anything to you, even with this so-called theory. It's not a theory. It's a description. Theories are not descriptions, and descriptions are not theories. A theory is an explanation. These people had to turn their descriptions into theories. Why? Because they had to somehow make sure that everybody out there understood that mathematics is a synonym of science. Mathematics is a synonym of physics. Why? Because physics is how the world works, and they claim, hey, mathematics can give us a clue or tell us exactly how the universe works. That's their notion, their line of reasoning for how science works, how physics works, and of course how math fits into all this stuff. Okay, interaction with the environment during a measurement procedure separates the wave packets in configuration space, which is where apparent wave function collapse comes from. What interaction, I say? What is interacting? So far they have no physical object. How can it interact? All they have is functions. How can a function interact with anything? How can a wave interact? How can it bang against something? They don't have physical things. They don't do physics with things. Okay? And that's the first rule of physics. You need to have a thing. Okay? Without a thing, you have nothing. Okay? That's the way I like to look at it. Okay, and one more, which was this. This is another interpretation. Okay, and it's the objective collapse model. Not necessary to go in any detail through this, because what they're saying is they modify Schrodinger's equation. That's math. It's got nothing to do with physics. Then they say they're talking about the behavior at the microscopic level. Okay, and again they're saying quantum object that is unmeasurably close to that given by the Schrodinger equation. Again, they're talking about numbers, functions, equations. They're talking about descriptions. They're not going to give you an explanation for what this objective collapse model, which is a theory according to them. What theory? You haven't explained anything. All you did is describe. It's like saying, I measured the table. Okay, so how much does it measure? Well, it measures 1 foot. It's a small table. Okay, and what have you explained? Is that science because you measured a table and you give a perfectly accurate reading? What the hell is that? Okay, it says for microscopic objects, the nonlinear modification becomes important and induces the collapse of the wave function. Again, collapse of the wave function. It's collapsing the function. They're trying to tell you that they're doing physics, that they're working with something real, some real object out there. When good old Nick told us just now that there is no such monster. Okay? And yeah, what is the mechanism? How does the wave function collapse? Please explain the mechanism. Put it on the board. Show us a movie of how the wave function collapses. I want to see it. I want to see it. Keep your mouth shut. I just want to see the movie. That way I can see how it collapsed. What are they going to put? A function? A bunch of A's and B's, X, Y's, and Z's? The main difference of objective collapse models compared to the other approaches is that they make falsifiable predictions that differ from standard quantum mechanics. Yeah, falsifiable prediction. What is that? Falsifying is an opinion. For you, God is false. For this other fellow, God is truth. Who's right? Who falsified who? Falsification is an opinion. Nothing more than an opinion. And they're falsifying predictions. That's even worse, because if you falsify a mechanism, you can say, well, let's go to the lab and find out. But these guys are talking about predictions. What are they talking about? Where the Scorpio is going to be in the sky someday, the sun or the moon. Are they talking about astrology? Is that what this is all about? What are my conclusions? Quantum measurement has to do with detecting the invisible and intangible. Can they detect the invisible and intangible? No, of course not. So there's no purpose in running any experiment in the lab, because you're not going to be able to touch or see what you're looking for. You got to define it and say, oh, this is what it is. Now you know what you're looking for. You say, I lost my wedding ring. Okay, what are you looking for? Well, I know what a wedding ring is. You know, you look for a ring, you're looking at some little hole there, right? So you know what you're looking for. But when these people say, you know, they're looking for something that is intangible and invisible, please draw it. So I know that I found it when I see it. You know, I mean, how are you gonna deal with something that's intangible and invisible except through visualization, through imagining it and drawing what's in your brain for someone else so that they can see the same thing you saw. Okay. Okay, there are no observers in science, but quantum is saying that the mathematicians, okay, can't see or detect the invisible mediators. So does observation play a role in science? If it does, then we have to eliminate quantum, because in quantum they tell you right up front that they can't observe whatever they're studying in the lab. So is observation part of science or not? And then the mathematicians insist, in spite of this, right, in doing experiments to see and detect them, to see and detect what can't be seen or detected. You know, and when you put them against the wall, they say, well, they continue to provide physical interpretations despite summarily dismissing all physical interpretations as philosophy. So you figure out, is that philosophy? Is telling me why a pen falls to the floor, is that philosophy or the mechanism, right? Or is that physics? And these people dismiss physical interpretations as philosophy. Then they give you a physical interpretation, the most idiotic, the most irrational one they can find. They tell you they cannot observe or see or detect it in any way. And then they say, come with me to the lab so you can see the experiment that I'm going to run to what? See and detect the unseeable, undetectable? So you figure it out if this quantum measurement is even a problem. Should we even pay any attention to quantum measurement? Does it have anything at all to do with physics? Let's go with the questions people asked. We can get them up here. Here's the first one. I can get it in there. Yeah, here it is. A fellow asks or says, quantum computing is far more capable. We dealt with quantum computing last time, okay? Is far more capable than conventional computers of solving equations we have not yet solved, okay? Or we have yet to solve, or whatever you wanted to say there. Yeah, it's fast. And so it calculates things we've never been able to calculate. So, is that science? We have an equation, that's science? What is an equation? A description, that's all it is. So, is that what science is? Just doing an equation and having computers develop more sophisticated equations, or solving them, or being faster at solving them? Is that it? Because it's really only a question of speed. It's a question of speed because they say that even a normal computer can solve these equations. It might take 100,000 years, but it'll solve the equation. And so now it's ultimately only a question of speed. That's all that quantum so-called computers buy us. And so if it's a question of speed, what does that have to do with science? It might have to do something with technology. Certainly it's got nothing to do with science. Especially if science is what? Explanation. They're not explaining anything with this, okay, with quantum computers. Okay, fellow says, I think it was the same fellow, yeah, says that I say that mathematics isn't a part of science or physics. Yeah, correctly. We don't use math in science. We don't use math in physics. For that, you have to do one thing first, and that is define what science is. You have to define what physics is, and here we define it, okay? And what is science? Science is rational explanations, okay? That's what science is. And we can defend that definition. If you have a different definition, no problem. But then you have to defend it. You can't just state something and say, well, that's what we all believe in. We don't care what you believe in. You know, we care what you can defend. That's what enters the realm of science. Okay, so keep that in mind. Okay, in the next issue he says, knowledge hasn't been defined. And I'm saying that knowledge hasn't been defined. Correct. Correct again. Number 2. And here it is. This is what knowledge is. Let's put it here. Knowledge today is essentially a variation of what Plato said, which was justified through belief. Knowledge is a synonym of belief. Okay? That's what knowledge is. When you know something, it's because you believe it. That's what you know, because you believe it. So you know that God exists because you believe that God exists. And the other guy knows that God doesn't exist because he believes that God doesn't exist. That's why knowledge has no place in science. Okay? Epistemology is the study of nature, origin, and scope of knowledge, epistemic justification, and the rationality of belief. Okay, again, what is the study of epistemology? It's the study of belief. Okay, and epistemology aims to answer the following questions, and here you can see why epistemology, meaning knowledge, has to do with belief. These are the types of questions it tries to answer. What do we know? In other words, what do we believe? What does it mean to say that we know something? What does it mean to say that we believe something? What makes justified beliefs justified? What makes beliefs? Yeah, it's all about beliefs. And how do we know what we know? In other words, how do we believe what we believe? That's all the person said. So yeah, knowledge has nothing to do with science, even though the word science derives from the word knowledge. It was mistaken by the people who derived it from there. And second, knowledge is just belief. So we don't deal with knowledge in science or with belief. Okay, and then the last one says, throw out scientific method. That I'm throwing out the scientific method, meaning really the mathematics method, the method of mathematics. And here it is. Here's the method of mathematics for all of you. Okay, what does it have? It has all these elements. It starts by gawking. You have to gawk in a mathematical method. You observe something with your drooling mouth wide open. It's important to have that mouth wide open to be drooling, okay? Otherwise, you're not observing. You gawk again. You have to repeat the observation. Otherwise, it's not part of the method, okay? Then you make you prophecy. You make a prophecy, okay, and you make a prediction, okay? Because prophecy, making predictions, is part of the mathematical method. They underline it, they underscore it, they say it's a very important part of the mathematical method, which is observation and prediction. Then here, you test your hunch with an experiment. And we just heard that quantum mechanics cannot do experiments on things that it cannot see or touch. So I don't know how they're going to test their hunch, okay, by doing an experiment. But that's what they do. And they measure, they calculate, they do some math, they come up with some kind of equation, okay, with which they describe an invisible mechanism, and they're going to call that a theory. They're going to call that description a theory. They propose the most ridiculous physical interpretation you can imagine. It's got to be ridiculous. Otherwise, it doesn't enter the world of mathematics, okay? You got to have a ridiculous and irrational explanation. Otherwise, you're going to be frowned upon. They're going to say, what do you think you are? You think you know? You think you know how this universe really runs? So, it's got to be ridiculous. Then they'll believe you. Then you got to sell it to high-placed individuals and ask them to give you a medal. Okay, that's important. And there you see them at the bottom, the sayings, and they hold hands, and you have to all hold hands and believe in the same thing. Okay, and then once you get your medal, well, you got to censor and treat as cranks and crackpots those who are skeptical of your theory. So if you have an irrational theory, and you're okay. And if someone is skeptical of that theory, you call them a crank. And you put your thumb on him like an ant. Okay? That's the way it works in mathematics. How does it work in real science? Well, here it is. I think this is it. Here it is. And it goes like this. You have the scientific method. What is science? Rational explanations, right? And these are the steps. Okay, and the steps are Hypothesis, in other words, the assumptions. You present the assumptions so that people can follow your explanation. That's what we're going to be doing here. Explanation, explaining. And you present the objects because you're going to explain a mechanism. You're going to have your definitions. Okay. Hopefully they don't rely on synonyms, meaning they're not circular definitions. And then you're going to present the first few frames, the initial scene essentially of what you're going to be explaining, what you're going to build your theory upon. Okay. And then you explain. An explanation, what are you going to explain? You're going to explain a mechanism or a cause. We're talking about physics again. So this is what you explain. And then you reach your conclusions, you know, your physical interpretations, your personal interpretations of how this thing could have happened, and give your conclusions, okay? Essentially. That's what it comes down to. And, you know, you have your corollaries, so on. So that is what we call the scientific method, okay? Okay, and I think I had one more here. Give me a second. Couple more, in fact. Here's the first one. If I take a pen and twirl it clockwise, okay. I didn't understand what the CW. Clockwise, the other end is twirling counterclockwise. Yeah, correctly. You take a pen, or pencil in this case, and if I twirled it, see if I can, I'll get my wand. I think you can see this better maybe, okay? And I'll twirl it around. So if I turn it, what is that? Counterclockwise, you should see it going clockwise, okay? Hope you can see that. I can't. And then here I'm turning it in the opposite direction. I'm turning it clockwise. Yours should go counterclockwise. So you can do that with a rope. You can do that with any elongated object you want. You can do it with a steel beam. Okay? You can use anything that's elongated. So he says, so this works on other objects besides ropes. Yeah, correctly. But not on other objects, just any other objects. You know, I could turn this little flat wafer, which I use to simulate the flat earthers, okay? And I can turn this one also, you know, counterclockwise. Your end should go clockwise, okay? But it's got to be a single entity. It's not very elongated, but whatever you have in your hands that you're twirling, the other guy's got to look at it from the other end so that they're both united so that they both go together, okay? The problem with quantum is they have particles. They have two particles, okay? Let me see if we can remove this for a second. They have two particles, okay? And here's one, here's the other one, okay? And if this one turns counterclockwise in my case, clockwise in your case, does this one move? Why would that one move unless they're connected? So they have to be connected. That's the issue. And that's where the rope model comes in, because with connection, you can explain a lot of phenomena. Without connection, without some binding, without some interconnectivity, well, then you cannot explain very much, because you cannot explain how one moves and the other one is influenced by it without having some kind of connection. That's the issue. So that's the critical point. And that's where the rope came in. Okay, and here's another comment, question. Person says, he says, let's suppose there is an electromagnetic rope perpendicular to spin of magnetic thread. Okay, then magnetic thread will collide with the electromagnetic rope or not. We don't know what you mean by collide, meaning touch. When you define touch, maybe we can answer your question. What do you mean by touch? And you can't use so don't look it up in the dictionary, because you can't use the words of ordinary speech. They're very easily destroyed. So if you want to use it, you're just going to waste your time. Now you have to come up with a definition of the word touch. Then we'll know whether the thread can touch the rope or the rope can touch the thread, okay? And whether they can collide, meaning touch, okay? So you got to define the word touch. We don't know what touch means. Please define it scientifically, and then we can follow your train of thought and answer your question, okay? So that's a little homework for you. Okay, and final issue It's got to do with this fellow Nick Lucid. Someone asked a question. In fact, asked a series of questions to Nick Lucid. He came here and posted them. I went to Nick Lucid's site to find out what he had said. Yeah, and this is what he said. He says, "An event horizon is the skin of this black ball." And Nick Lucid answers, kind of, yeah. A very definite answer, okay, kind of. Is it a solid black ball? No, it's just a region of space. That's what a black hole is. Just a region of space. So it's not a black ball. It doesn't have size. It's not a thing. It's not an object. What it is a region of space. What is space? Nothing. So we have a region of nothing, and that's what a black hole is. And he says, do black holes crush matter out of existence? When you have some PhDs out there that state it, directly, and I've already covered that in the past. And he said, we don't know, because we can't receive anything from inside the event horizon. So those are your definite statements from Nick Lucid, a physicist, or so-called physicist, a mathematical physicist. And these are the people who run the show, and these are the people who censor everybody else. Okay. Okay, with that, I'll see you next time, which will be on Sunday. We'll see you later.